In this video, we're going to talk about reference angles. Reference angles are very easy to find, and once we've graphed our angle in standard position, we only have very few ways that we need to solve for the reference angle. It all depends upon what quadrant our standard angle lies. So just real quick, a reference angle, it's just the acute angle formed by the terminal side and the x-axis after we've graphed our angle in standard position. So looking right here, I can see that here is our angle that we have graphed. Whatever the acute angle, the angle less than 90 degrees, is that is formed with our terminal side and the x-axis, that's our reference angle. One thing that I always tell my students is that it's the fastest way back. It's the fastest way from the terminal side to the x-axis. So meaning, if this is my terminal side right here, what's the fastest way back to the x-axis? It's not this way, it's definitely this way. And then you've just got to find the measurement of that angle. So I'm going to give you a few different examples to just find your reference angle. Again, it all depends upon what quadrant we are in for how we solve them. So let's look at this first one. Quadrant 1 is the easiest reference angle to find. The reason for that is your reference angle is always acute. So we are always acute, and we are always positive. So when you start thinking about what is the fastest way back from our terminal side to the x-axis, well, it's straight back this way. Well, what is the measurement of that angle there? They've already given it to us. Our reference angle is 46 degrees. That's the symbol for angle. Reference angle is 46 degrees. If you are in quadrant 1, your standard position angle is always your reference angle. It is its own reference angle, okay? So in quadrant 1, your standard position angle is always its own reference angle. Quadrant 1 is the easiest one, all right? Let's look at example number 2. Example number 2, they give us this angle saying that it's 141 degrees. They want us to find the reference angle. So again, remember, it's always positive and it's always acute. It's the fastest way back from that terminal side back to the x-axis. Well, if this is the fastest way back, what's the measurement of theta? Well, we know this is 180 degrees. So 180 degrees minus 141 degrees is going to be 39 degrees. That is our reference angle. Since we get 39 degrees here, our reference angle is 39. So in quadrant 2, it's always going to be 180 minus your standard position angle to find your reference angle. Again, super simple. Let's try another one. Quadrant 3. So in quadrant 3, we have this angle measure where our terminal side falls at 250 degrees. Well, fastest way back to the x-axis is definitely going to be this way. So what is the measurement of theta? Well, when we're in quadrant 3, we are going to follow our standard position angle minus back to 180 degrees. And that is going to give us 70 degrees. So our reference angle for this example is 70 degrees. So again, when we are in quadrant 3, we follow our pattern of our standard position angle, our terminal side, minus 180 degrees. That gives us our quadrant 3 reference angle. Finally, in quadrant 4, we have 332 degrees. Fastest way back to the x-axis is going back to the positive side of the x-axis. I want to know what is the measurement of theta. So when I am in quadrant 4, my method is simply taking, I know this is 0, but we're definitely past 0. I also know all the way around is 360 degrees. So my steps for finding my reference angle in quadrant 4 is going to be 360 degrees minus your standard position angle. So 360 minus 332 gives us 28 degrees. Our reference angle here is 28 degrees, and that kind of looks like 280. Easy. So again, just depending upon what quadrant we're in, we're going to follow those very simple steps. All right. I want to go over one more quick example, just in case we are ever dealing with a negative angle where our standard position angle has been negative. I want to find the reference angle. Well, remember, reference angles are always positive. It's always acute, and it's always the fastest way back to our x-axis. So I know that this is negative 180 degrees. So I'm going to follow it the exact same way. So we have negative 180 minus negative 115. Well, we know that those are going to change there, giving us kind of an addition problem. And we know that this is going to be negative 65 degrees. All right, so our reference angle, we got negative 65. But remember, your reference angle is always positive. It's always the distance, so it's going to be 65 degrees. Okay? So I hope this video helps you guys understand reference angles and how you solve for them depending upon what quadrant you're in. Thanks for checking out the video, and I'll see you guys next time.